turn on this light. Okay, how's everybody doing? Good, good, good. Okay, we did finish up the lesson yesterday, but there was something we started talking about, and I said I would go ahead and check with the calculus teacher, and we were correct. There is one correction we need to go ahead and make, and it was on this problem right here. So we were correct. I was just thinking about the zeros, but if it's a decimal value at all, you want to go ahead and apply that idea. So we were correct to go ahead and do that with B. Okay, so that's good. But we actually don't have the right values for A because we need to go ahead and do the same thing. We need to take the 2.16 and then add and subtract both 0.005. Okay, so that's going to change this, and that'll change this as well. And my timer's going off. That's weird. Okay. But is everybody okay with where I'm getting the 0.005 from? We first saw this yesterday when we had the example, the 7.0, because there was the one decimal place, we were taking 1/2 of the 1/10. And we have that right there. So here, with the two decimal places, we're taking 1/2 of 1/100ths. All right, for the two decimal places. So the 1/200ths is that 0.005. So somebody help me out. What is a 2.16 if I were to go ahead and subtract 0.005? Okay, 2.155, less than or equal to A, which is less than 2.16 plus 0.005. 2.165. There we go. And then now to go ahead and get the range for the product, I'd go ahead and multiply these values. Okay. See, we didn't have to do those on the other ones because there were no decimals, so we didn't have to worry about multiplying by the decimal place. Is everybody okay with that? Okay, so that was my fault. Okay, so got that corrected. But let's go ahead and figure out what the product is going to be. 2.155 times, I think it was 3.495. Okay, so we got that one. And then we also have 2.165 times 505? Okay. All right. And then we're wanting to stick with the same number of significant figures, so I'd go ahead and say 7.53 and what? 7.59. So 7.53, 7.59 is going to be the range of values for the product. Okay. Did anybody have any questions on that one? Okay, so with that, like I said, I'm not going to go ahead and give you the homework assignment. This is not going to appear on what tomorrow? Okay, your test. In fact, for the rest of the period, we're just going to go ahead and look at that probability review and answer any questions that you guys might have. Now, remember, the review itself, you can do what? You can use that on your exam. So anything you want to write on there is fair game. In fact, we're going to go ahead and turn that in tomorrow with your test, because I'm going to go ahead and take a participation grade on that. But let's go ahead and get to that. Probability review. Okay. And also one other thing, I'm pretty sure, yes ma'am. Are you sure? Okay. I'm pretty sure that I went ahead and gave you one of these at the beginning of the school year, but I wasn't 100% sure, so I went ahead and copied these. Again, did I give this to you? Okay, all right. So again, just another item to help you along with your internal assessment as you're going through writing your paper. You know, it's kind of checking off, did I get this? Did I get that taken care of? You know, definitely be looking at the criteria. Okay, the 7 criteria, starting with the introduction, the quality and quantity of data, and all that good stuff, the math strategies. Because when's that going to be due? December 13th is when the rough draft is going to be due. So I told you yesterday for the first time when we come back on Monday the 26th, I've got a little in-class assignment. We're going to go ahead and work together to help you remember the material we just covered. Then I'll go ahead and give you the homework assignment on that. And then for at least the next couple of days, that Tuesday and Wednesday, okay, I'm going to go ahead and give you the class time to work on your IA. If you have any questions about what to do with the data, or if you want me to check over things, we're going to have a little bit of time to do that. Gabby.
Since I won't be here Thursday or Friday, can I go ahead and have the homework assignment? assignment, or are you going to wait until after?
Oh, it's after the break. Yes, I will not be giving you anything during the break. Okay. Now, having said that, I do want to go ahead and say, while I'm not going to be giving you any homework or anything to study for over the break, it is an excellent opportunity to work on your IA. You don't have to worry about school, or you may have something to do for another class, but at least you won't have to be here every day, Monday through Friday. You'll have a little extra time, and it is perfect to go ahead and take a look at that if you haven't done anything yet. Has anybody already written their rough draft? Okay, that's fine. That's fine. How many people have their data? Okay, so definitely one thing we'd probably want to go ahead and do is make sure we have data at least so that we can go over questions on that. Okay, so as far as the review goes, did we just want to go through these one by one? Did you have just some random questions you wanted to ask? What would you guys like to do? Emily? Just one by one? Okay. Well, let's go ahead and take a look at the first one. The probability of R equals 0.4. The probability of S is equal to 0.5. And the probability of the union of R and S is 0.7. Are R and S independent events? Okay. So how can I answer that question? It's either yes or no. I'm sorry?
We can look at the union.
Look at the union? What about the union?
So since the union's 0.7, if they were independent, you just add the probability of R and the probability of S. But since they're not independent.
I think you're referring to mutually exclusive.
Oh, are they? Oh, those two different things.
Yes.
Oh, okay.
Yes, yes. Okay. Spencer, what do you think?
They're independent, the intersection should be the same as their probabilities multiplied.
There you go. There you go. So let's go ahead and do that. Let's go ahead and create a Venn diagram for this thing. That'd be a lot faster than mine getting the figures out. So let's see. We have the probability. Let's say this is R, this is S. Of course, the universe would be 1. Now, we know that the union of both is going to be 0.7, right? So that means somewhere in the rectangle, we have 0.3 that's not going to be occurring. Okay. So if I add all 3 parts, I should be getting 0.7. So how is that going to help me find, say, one specific event or even the intersection? Okay, Eli, what do you think?
You can subtract 0.4 from 0.7.
Okay.
And get the crescent of S.
That's exactly right. Because I know the probability of R is 0.4, so this whole circle here has to be 0.4, but all 3 added up have to give me 0.7. So yeah, that difference would have to be 0.3. And see, now we can go ahead and start to work backwards. S was what? 0.5, so that means our intersection should be 0.2. Okay, and then what's the crescent for R? 0.2 as well. There we go. And this is what Spencer was saying just a moment ago. If the 2 events are indeed independent, I should be able to take the probability of one times the probability of the other one, and that would give me the probability of the intersection. But this only applies if they are independent. Well, let's see here. 0.4 times 0.5, what would that give me? It is 0.2, and that is the intersection we see in our Venn diagram. So yes, whatever these events are representing, they are going to be independent.
Oh, okay.
Is everybody okay with that?
Yeah. I just didn't know that was what it meant.
Okay, okay. And now we know. Hey.
One of those calculators is
If I have any more, it would be over here. Should be right over here in the files, the pockets. Okay. All right, number 2. Let's see here. If the probability of A equals 2/5, the probability of B is 1/3, and the probability of A union B equals 1/2, we want to find the probability of the intersection. Okay, so let's go ahead and do the exact same thing. I'm going to draw it down here so I have a little more room, like Venn diagrams. All right, so we've got A and B, so let's say this is A, this is B. Okay, so we have A is 2/5, B is 1/3, and the union is 1/2. So we could do the exact same thing we did a moment ago. Now we're just working with fractions. Okay, so where should anybody tell me what one of these values should be?
The universe could be 1/2. Like everything else.
Okay, now what's left in the universe, but
Not in the Venn diagram.
there we go, not in the circles. There we go. Because the union of the two, yeah, is 1/2, so there has to be half left in the universe. Okay. All right, so how are we going to start? Would we like to try to figure out A first or B first? Okay. Really doesn't matter, no, when it comes down to it. I mean, let's go ahead and start with A. I know that this whole circle has to be 2/5. Okay. But that all three sections together with the intersection is going to be 1/2. So I could just do what? What did we do on the previous one? Subtract the 2. So I'm going to go ahead and take the union 1/2, and I'm going to subtract off 2/5. Okay, we need a common denominator, which would be 10. All right, so what's the equivalent fraction here?
5/10.
Okay, 5/10. Ooh, almost 2/10. I really like that joke. I'm not going to
This
let
is
it go.
really intense.
Oh, there you go. And what would the other one be? 4/10. So I'm looking at 1/10. All right. Now, because we just subtracted the union in A, this is actually what? The crescent B. There we go. So this is going to be 1/10. Okay. But B is only 1/3. So now if I were to go ahead and subtract the 2, what would I get for the intersection?
I don't know.
What's that? 1/6? No. I got 7/30. Okay, how do we get that? All right. Well, are we okay with how we got the 1/10? Okay. So now we know that the entire circle of B has to be 1/3, right? And we've already got a portion of it is 1/10. So I'm just going to subtract the 2. The whole minus the portion. So the common denominator would be 30. Okay, so this is going to be what? Okay, 10/30 minus 3/30. And then we're going to end up with our 7/30. And now we're going to do the exact same thing to figure out what the solid portion for A is. The whole A of a circle should be 2/5, but we got a portion of it to be 7/30. What should we get for that last one? 1/6. That's what I got for A. That's where you got the 1/6. Okay, there we go. All right, good. Does anybody want me to go ahead and work through how I got the 1/6? Kind of show that algebra, or are we okay? You do want to see it, or you're shaking your head okay? Yes, you want to see it. Okay. So I'm going to go ahead and take the 2/5, and I'm going to subtract off the 7/30, if it will let me write. That's supposed to be a 30. All right, so the common denominator would be 30, so I got to multiply this by 6. Looks like we're looking at 12/30, and then we're going to subtract off the 7/30, which gives me what? 5/30, but they have a common factor in 5, which is where the 1/6 comes from. Okay. All right, not many people do enjoy working with fractions. I mean, 3 out of 2 people will tell you that. No, that was a joke, yeah. That was a joke, yeah. Okay. But Samir, yes.
So since the whole idea of making it difficult with fractions, I did it a different way. I just converted each fraction into decimals, and that worked out.
That'll work. I mean, that works out just fine. Every time I have the opportunity to go ahead and work with fractions, I always go ahead and do it. Because I always think people could use the practice. I don't think it's a bad idea. But if it makes it easier for you, I mean, our ultimate goal is just to get the right answer. So there you go. That's absolutely right. Okay, so now we got the Venn diagram taken care of. So the first one I want is the probability of the intersection of A and B. Okay, and what would that be? 7/30. I mean, we see right there, the intersection is 7/30. Okay, now what is this right here with that little line segment? Okay, the probability of B given A. This is our conditional probability. So the formula is going to be very specific to how this is written. So this is going to be the probability of B intersecting A divided by what? The probability of A. Whatever the given event is, that's the probability that you always divide by. So let's see, the intersection is 7/30ths. And I'm going to divide that by the probability of A, but we know the probability of A is what? 2/5. And what happens when we divide by a fraction? We multiply by the reciprocal. So let's see, this is going to give me 7/30ths times 5/2. So let's see, I always like to go ahead and simplify on the diagonals before I do anything else. So a common factor is 5. So it looks to me we're getting what? 7/12. 7/12. Okay. All right. Would anybody want to come on up and show me how to do number 2, part 3, the probability of A given B? Okay, let's start with Eli. All right, let me go ahead and take this off right here. Now, what's the one change I would make in the formula? Just the denominator. Okay, we always divide by the probability of the given event. That's right.
The intersection was 7/30ths over probability of B was 1/3. 1/3. So we do.
I'm sorry.
Can I erase this so I can?
Sure.
So now, then when we multiply it, it's 7/30ths.
Yeah, it does that sometimes.
7/30ths times 3/1.
Okay.
And so we have 21/30ths. Which is 7/10.
There you go. All right. 7/10. Perfect. This is exactly right. Okay, good. All right. Now, I'm going to go ahead and start getting you folks up here to help me out with the rest of these problems, but I'll let you decide, do we want to go ahead and start just doing a train, with the most current person choosing who they want to come up, or do you just want a random number generator?
Choose.
I'm sorry?
Choose.
You want to be able to choose? Eli, who do you like for the next problem? Spencer is going to help me out with number 3. Now, there are multiple parts to this one, so I guess I'll leave it up to you. Spencer, did you want to do all 5, or did you want to go ahead and do 1 and then give it to somebody else?
Do 1.
Do 1, all right. Okay, so the probability of x equals 0.5, the probability of y equals 0.7.
Instead, because I didn't answer that.
Oh, I'm sorry, did we skip? Oh, I'm sorry, we did skip one. So, yes or no, are A and B independent events?
Yes.
Remember, what was the intersection? What was the intersection of our Venn diagram we just had? It was 7/30ths, right? So if they're independent, what should happen? Okay, the product of their individual probabilities should match that intersection. Will 2/5 times 1/3 give me 7/30ths? No, so they are not independent. Whatever they are, one is affecting the other one. Okay.
Do occur and do not occur.
Okay, nice. There you go. You're going to go across the top branch. 0.35. That's exactly right. Okay, so now I'm looking for the probability of x or y occurring.
So then, if x or y occurring, so then here both can occur. So 0.5, 0.7, you would multiply those, right? So then it'd be 0.1, okay, and then another point. Another 0.5, 0.35. So then
That's
A little high.
1 is 0.3, not 0.5, so it's a 0.5.
oh, well, so then it would be 0.15.
Well, see, he's got X or Y. So is it okay if both occur at the same time? Or one individually? So he is correct. We need to get 3 of those products. 0.65? What do you guys think?
Yeah.
What I said bottom is on Y, the top branch.
Yeah, it would
the
be
bottom
0.7.
one is 0.3, so it's 0.35, 0.15, and then the other point.
A 0.35.
Oh, another point.
Yes. Okay. Do you see why? Okay. So that should be 0.85. There we go. Okay. All right. Good, good, good. And I guess it just also shows, what personal people like. I always tend to go for the Venn diagram a lot of times. Did anybody out there want to go ahead and draw the Venn diagram if you're having trouble following this? Or is everybody okay with how we got those 3 values? Okay, Samir, who's up? Haley. Neither X nor Y. There you go. Exactly right. And what we're demonstrating here, remember, if you're going along a branch, that's an intersection. If more than one branch has your outcome, taking the sum of those, that's your union. Okay, Haley, who's up? John. I love how people avoid eye contact when it's time to choose. All right. Okay, so John, we want X happening, but not Y. So we need a branch that describes that. Okay, do you want to go ahead and you want me to draw it for you again?
Yeah.
Okay. Keep that. Okay. So we have X is either, I think, how'd you do it as circle and then occur and not occur? So occur and not occur. So it was a 0.5 that X is going to happen. So that would be a 0.5 that it doesn't. And then off each one of these, we have Y occurring or not occurring. Okay, and it was 0.7, so he had 0.7, 0.3, 0.7, 0.3. That's supposed to be a point. Okay, so we want X to happen, to occur, but not Y. So is there a branch where X happens and Y does not?
Yes.
Okay.
Right here, so it would be 0.5 plus 0.3.
Now plus. Times, there we go. When you're going along the same branch, you multiply, you only add the product of those branches if more than one has the outcome you want.
So it'd be 0.15.
That's it. It'd be 0.5 or 1.5, yeah, 15%. Okay, good, good, good. John, who's going to have that conditional probability? X given that Y occurs. Okay. So Louise, he has got E. Now, it's not written in the notation, but we know we're going to write this as a fraction. What would have to go in the numerator? The probability of what? Of X intersecting Y, and then we would divide that by 0.7, the probability of Y occurring. Yes. That's what you do here. So do we know the intersection of X and Y? Yes, we just found that to be what? In fact, we found it in a previous one. 0.35, right? Okay, because that is the very top branch. Okay, then what does he do? There we go. So 0.35, that's the intersection. And they said to divide by 0.7.
So we divide that by 0.7.
Mm-hmm. That's exactly right. 0.35 divided by 0.7 is 0.5. Yes. So we have a 50% chance that X will occur given that Y occurs. Good, 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 good. Okay. Now, I really like this next one right here. The probabilities that A, B, and C can solve a particular problem are 3/5, 2/3, and 1/2 respectively. If they all try, determine the probability that at least one of the group solves the problem. Okay, so if you were to go ahead and create a tree diagram based on this one, I'll go ahead and show you how I solved this one. Okay, let's say we go ahead and start with the first one, A, which is 3/5, right? So there is a 3/5 chance that A occurs, and there's a 2/5 chance that A does not occur. So I'll put NA for not A. Does that make sense? And then you could do the same thing for B. Okay. Let me go ahead and set it up. Yeah, I'll go ahead and set the whole thing up. Why not? So B. Why did I put A there? What did I put A for? Oh, okay, that's why. Okay, okay. Man, I'm old. I kind of lost my train of thought there for a second. La, la, la. Okay, B. Not B. This is when you're supposed to say, no, Mr. West, you're not that old. I still don't hear anything. Okay. I don't want your pity. All right. C and then not C, C and then not C, C, not C, C, not C. Okay. And then you could go ahead and fill in all the corresponding probabilities, which is what we need. But I like to think that I kind of got a little creative on this one. The question says, determine the probability that at least one of the group solves the problem. Okay, so we're looking for any branch where at least one person solves it, right? Where at least one person is a yes. So what I did, I found the probability, instead of going through the whole diagram, I found the probability of none of them solving it. And then I subtracted that from what? 1. Because you're going to use every branch except one, the very last one. Okay. And here's what it did. We know that there is a 2/5 probability that A will not solve it. B solving it was 2/3. So that means there's a 1/3 probability that B won't solve it. And then for C, there's a 1/2 probability he will. So I'm going to say there's a 1/2 probability that he won't. So the probability that none of them will solve it would be what? That would be 1/15. Okay. So I'm going to take the probability of the whole, 100%, and minus the probability that none of them will solve it, because every other outcome has at least one person solving it. So on this one, I got 14 15s. I thought that one was just really cool. Did anybody else think to solve it that way? No, I don't know. I mean, ask my wife. I'm not that cool. Oh, I'm kidding. I'm kidding. I'm the center of her universe. How scary is that? Okay. I'm just making a joke. Come on. We're okay. Hey, I have a happy family. I got beautiful children over here. Everybody's like, oh my God, Mr. West. I'm sorry, what? That I'm the center of her universe? No, she's never said that. I just like to think I am. I'm her rock. Well, yeah, probably not. Okay. But I'm just kind of curious for the rest of the problem. Did anybody else go through every one of the branches? Did anybody solve it similar to this?
Oh, no, I went to every one of them.
You went through every one of the branches? Okay. Did anybody do anything else? Okay. All right. So I went ahead and took over that one. Like I said, I just thought that one was kind of neat. Instead of going through all that work, just kind of cut to the end. Okay. Number 5. So who was the last person up here? Okay, Louise. Who would you like to see come up and do number 5? Kiana. All right. Let me go ahead and pull this down. Oh. Let me go ahead and pull that down for you, ma'am. There we go. Okay, so it says suppose the intersection of A and B equals 0.1, and the probability of the intersection of A and B's complement is 0.4. Find the union of A and B's complement given that A and B are independent. Okay, there's that word again, independent.
Which means that both of them have to equal their intersection.
Well, that means whatever their individual probabilities are, they would multiply and give you that intersection 0.1.
So what's the first? Yes.
Sure.
So if A times B equals 0.1,
Mhm.
and we know that everything in A is 0.4, you can divide 0.1 by 0.4 to get.
Well, not everything in A. Remember, we know that the intersection of A and B's complement.
Yeah,
So that would just be the crescent, right? Okay. So the probability of A is actually what? 0.5.
Should we draw a Venn diagram?
Sure.
They're gonna laugh at me.
No. Oh, she's doing it. Yay! And Kiana, I want to go ahead and point out, you can draw it down here. You don't have to. There you go.
I do that.
I didn't want you to come up a little short or anything. Oop, sorry. That was my fault.
Okay. So, 0.1, correct?
Yes, that's 0.1.
And then everything. That's not gonna be. Would this be 0.4?
So that would be yes. There we go. So see, now we know that the probability of A is actually equal to what?
5.
0.5.
Oh yeah.
And we can use that to help me figure out what? The probability of B. Because now that I know a portion of B is 0.1, we can figure out what the other portion has to be. So Kiana, are you okay?
Yeah, I'm trying to figure it out.
Okay. Well, let me go ahead and write this out for you real fast. Let me help you out. Oh, I'm just helping her set up the Venn diagram. Okay. Been there, done that, Probability of A times the probability of B is equal to the probability of A intersecting B. Okay.
And we know A
There you go. So now we can plug in. And we know the intersection.
So we divide this by 0.2,
Yes.
which is do that.
Now we know. Now be careful. We know that probability of B is 0.2, but remember we've already got a portion of that is 0.1. So another 0.1 would give me the 0.2. And are we missing anything else in the Venn diagram? Yes, there we go. Excellent.
So this has to times this equal this, so no.
I'm sorry? Oh, no, this one isn't a yes or no. We want to find the probability of the union of A and B's complement given
Oh, we
that A and B are independent.
Okay. I'm sorry.
That's fine. So we just want the probability of A union B complement.
So that A union whatever is not part of B, which would include the 0.4, right?
Yes.
So that'd be 0.8 union 4. So would it be or 0.5?
0.5? Not 0.5.
Just solely everything that's not in B, so that's 0.8. So this
But we want to combine that with everything from A.
so unit
So we've actually seen this type of problem before. Would that include the intersection 0.1? Yes.
so 0.8 union 0.5.
So 0.9, yes.
Wow.
Hey, that's fine. That's fine. And again, I think another advantage to doing the Venn diagrams, if you want to go ahead and shade it in, see, remember the union, I want the combination of everything outside of B, so I'm definitely going to take everything out here, that's B's complement, but I want to combine that with A. Now, even though this is part of B, it belongs to A, and I'm going to include it in the union. So we have the 0.4 plus the 0.1 plus the 0.4. So, oh, okay. So are you okay with the equation? So what we did, basically, she just went ahead and divided through, so we knew that the probability of B should equal the probability of the intersection, which is 0.1, divided by the 0.5 we had for A. So, it's just working with the decimals. On a problem like this, what I like to do is kind of change them to fractions. 1/10 divided by 1/2. And then go ahead and multiply by the reciprocal. So 1/10 times 2 over 1 would give me 1/5. And I know that 1/5 is 0.2. Oh, well, let me go back over here. Okay, so we know that if two events are independent, then the probability of the product of their probabilities should equal the probability of their intersection, right? So I just plugged in everything I had kind of like a variable. I knew that the probability of the intersection was 0.1. Okay, we don't know what the probability of B was, but we know that the probability of A was, we found that to be 0.5. So I went ahead and divided through, just like I was working an equation. So see, those canceled, the probability of B equals that ratio. Does that kind of help? Okay. All right. Good. What else? Okay. All right. Next up, who was up here? Kiana. All right. No hesitation. Araya's got number 6, or at least 6A. 6A1, I'll say. All right, she's got 3 red, 10 white, 5 blue, and 2 green counters are put into a bag. If one is picked at random, calculate the probability that it is green.
Is it 1/10?
Is it 1/10? There you go. Do you want to?
Well, I'm just asking.
It's up to you. All right. Now, is everybody okay with why the green counter is 1/10? Okay, there were 2 greens out of the total 20. Okay. Now we're looking for a blue counter.
And then
So that's 5 out of 20. That's 1/4. Okay. And Jocelyn's up next. So now, if the first counter taken is green, but is not put back in the bag, calculate the probability that the second counter picked is a green counter. Okay. That's part of it. Now remember what's already taken place. We've already pulled out what? One green counter, but we're not going to put it back. So we want to know the probability of pulling out the second one, but we've already pulled out the first, so we have to account for that, which is why you went ahead and subtracted the 1 off the 20. So what are we going to have to do with those two probabilities? We're going to have to multiply them.
20th.
I'm sorry?
2/20.
Times 2/20. Or 1/10, whatever you want to do. Okay, so I'm looking for 1/19 times 1/10. 1 over 190. So very low odds. Okay. Oh, wow. Well, think if you were going to go ahead and visualize this, you're looking for the branch where you first pull out a green. Okay. Do you have the marker? Oh. All right. You're looking for the one particular branch where you pulled out a green, and then without putting the green back, you get another green. So really, you're looking for the intersection of these two events. Well, we already figured out the probability of pulling out a green counter. Remember, there were 2 out of 20, which is where we got the 1/10, right? But if we're not going to go ahead and put the first green back in, we only have 19 left in the bag now, and there's only 1 green left. See, there's only one way to go ahead and get the 2 greens.
Would it just be 1/19 just be the answer? Because all you're doing, because we already know that the first counter being picked out is green. So,
Because you're just looking for the second.
so all we're just finding is probability of finding a second green counter. We don't need to know the probability of getting greens.
No, the resource said 1 out of 190.
Yeah, because if you
Yeah.
don't find the probability, what if you got a red?
Oh, so we
Yeah.
are looking.
Because you have to find.
Yeah, so we're looking for the overall probability. So you have to account for the first
So
one.
we don't know that the first one being picked out is green. We're still looking for the probability
Yeah,
that the first one being picked out is green.
Yes.
Okay, because the way I read it, it made it seem like weird, like the green
Okay.
one had already been picked.
All right. Zoe, is that where you were having your misunderstanding? Okay. Oh, you still don't understand it?
We could.
Oh, well, Does anybody think they have another way they could describe that? I'm kind of at a loss right now to try and think of another way to. Oh, Libby, you had a question?
I just want to figure out why. When I think everyone takes one thing out of the back,
Uh-huh.
all probabilities. So like the new probability of that number
Yes.
times what it would have been.
Now, see, this is a big change. This is without replacement. Had I put the green back in, then this would be what? It would actually be 1/100ths, because the probability of getting a green would remain constant.
Wait, but if you had left the green in and there was only a second green, wouldn't it be?
But see, if I put the green back in, there are still, again, 2 greens for me to choose out of the total 20, because I replaced that one. What are we calling these, chips or what? Counters. Now, see, the reason we subtracted 1 from each, we had 2 green and 20 counters. If I pull out a green, then I've only got 1 left, and if there was 20 to begin with and I don't put it back, I've got 19.
Wait,
Okay.
I still don't understand why it's still 1/19 because all it's like the probability. Yeah.
Green,
but-
and it's not put back in the bag. Calculate probability.
Well, but no, I'm not saying it's a given.
Well, see, but think about this. The way I'm looking at this, the only way this probability occurs is if the original probability has to happen. So you have to take a product of the two. I think what we're doing here is looking for the over. Is that the bell already?
Yes.
Good Lord. Okay, time flies when you're having fun. So we didn't get to finish the rest of them. Would you want me to go ahead and post these answers?
Yes.
Okay, I'll go ahead and do that right now. Please remember to bring this with you tomorrow. You can use it during the test. We are going to be turning it in with the exam. Okay. Thank you very much, folks. Great job today.
Sorry.
Yes. Oh, that was the one I gave you that had the classes, like the botany and the art, the one that had 2 problems on one side and one on the other. I think I gave it to you, it was either a day or 2 ago.
Yeah.
That's the one it's talking about.